Hello, so our topic for today would be about minimizing kinetic friction. There we go. So first, we have this problem. A woman at an airport is pulling her 20-kilogram suitcase. So that is her suitcase. That weighs 20 kilograms. At constant speed by pulling on a strap at an angle above the horizontal. So there's the angle. She pulls on the strap with a 35 Newton force. So there's a 35 Newton force. 35 Newton force. And the friction force on the suitcase is 20 newtons. Friction force. What angle does the strap make with the horizontal? So first is, what is the angle? And letter B, what normal force does the ground exert on the suitcase? So we'll plot the remaining forces acting upon the suitcase. So we have the normal force and the weight. So here's our force body diagram. Since the tension of 35 newtons is not along the x and y axis, we have to plot again. So using the x and y axis, we will have, this is our x, this is our y, and this is our angle. So for t of x, we will have t cosine theta, and t of y is t sine theta. So for the summation of our forces, we will have summation of forces in y is equal to normal force minus the weight plus t sine theta from this diagram. So from that we would get normal force would be equal to weight minus t sine theta. For the summation of forces of x, we have t t cosine theta minus the friction force. That would be equal to 0. This also would be equal to 0. So t cosine theta would equate to the friction force. Since we don't have cosine theta, we will derive this formula. Theta would be equivalent to our cosine friction force divided by T, or the tension. So from that equation, we will just replace it from the given. Our friction force is 20 Newton divided by the tension of 35 Newton. That would be equal, and we will get the arc cosine of that. And that would be equal to 55.15 degrees. Since we already have the value for theta, we would use this in this equation. So normal force is equal to the weight. Since the weight is in kilograms, that would be 20 kilograms times 9.8. That would be equal to 196 newtons. So 196 newtons minus T for tension, that is 35 newtons, times sine 55.15. That would be equal to 167.277 So, our final answer would be normal force is 167.28 newtons, while the angle made by the strap of the suitcase is 51.15 degrees. So that is our given problem and equation for minimizing kinetic friction. Again, I am Alisa Marie Tilungka, the problem solver for today. Thank you and God bless.